Hello physical science students, you are now on lesson 2.2, velocity and momentum. So velocity, should be writing down, speed describes only how fast something is moving. To determine direction, you need to know velocity. So what's the difference between velocity and speed? It's this right here, direction. So velocity includes the speed of an object and its direction of motion. That's really the only difference. So instead of saying I'm going 20 miles per hour, it would be for velocity, I'm going 20 miles per hour east. That's the only difference. So let's just listen for a second. Relative motion. If you're sitting in a chair reading the sentence, you are moving. You're not moving relative to your desk or your school building, but you are moving relative to the other planets in the solar system and the sun. So the choice of a reference point affects how you describe motion. So if the house is chosen as a reference point, how would you describe the motion of a car and a hurricane below? After taking a time to take a look at these two, this one's 2 o'clock, this one's 3 o'clock. Here's your house. Here's your house. Here's the hurricane. Here's the hurricane. Notice the travel. Okay. And after you take a look at that, I want you to answer that question and highlight it. I will be checking it in class. Okay, so same scenario. If the car instead of the house, so now if the car is the reference point, how would you describe the motion of the hurricane and the house? Please write your answer and highlight it. Momentum. Write this down. A moving object has a property called momentum that is related to how much force is needed in order to change its motion. So, in short, the momentum of an object is the product of its mass and velocity. You'll need that whole page. Momentum is given the symbol P and can be calculated with the following equation. So write down momentum equation. Momentum in kilograms times meters per second equals mass in kilograms times velocity in meters per second. So in short, P equals mv. The unit for momentum is kg times meters per second. Notice that momentum has a direction because velocity has a direction. So here's our problem. Write it down. At the end of a race, a sprinter with a mass of 80 kilograms has a velocity of 10 meters per second east. What is the sprinter's momentum? Again, just like last lesson, we're going to analyze what we know. We don't know the momentum, which is P. Okay? So we're going to set it up just like an equation. So we don't know P. But we do know is 80 kilograms for the mass, and the velocity was equal to 10 meters per second east. So we're going to come over here, we're going to set that up, and then solve the problem. And the problem's answer is 80 kilograms of meters per second east. So our answer makes sense because it's greater than the momentum of a walking person, but much smaller than the momentum of a car on a highway. So we'll be writing down everything on this page as well. What is the momentum of a car with a mass of 1,300 kilograms traveling north at the speed of 28 meters per second? So we've identified that we do not know the momentum, right? And we've listed our knowns. So again, we're setting up the problem. P equals mv equals 1,300 kilograms times 28 meters per second north. And solving the problem, this is our answer, 36,400. Make sure you're writing down these examples because you will need them for future projects that you will be doing together in class. Momentum. When two objects have the same velocity, the object with the larger mass has the larger momentum. Note the example that was given to you in your notes, please, and this concludes this lesson.